Oh, hi. This is the front-end web development class. My name's Jeffrey. I'm going to start, I'm going to look for, still kind of waiting around this terrible user interface and looking for how I can open up the chat for the currently in progress thing that's going on right now. There we go. View live now. Live control room. Good. The health is good. That's nice. And open a live chat. Okay. Guess I'll just leave that there. Cool. All right, so let's let's do our recap. This week we're going to be talking about HTTP, SFTP, the like. We're eventually going to be taking the site that we built last week and putting it on the internet. Actually putting it on the internet where people can access it. If it wasn't apparent, all the classes that we've done so far, all the previous stuff, has pretty much just all been local development. Everything we've been doing is only accessible from our computer. When I was very young, and I'm making my first website at the age of 9, I totally thought that basically just creating any web page and being able to open it up in my browser and just link to a few images somewhere on the computer meant that anybody in the entire world could see them, which is very disappointing when I put the HTML file on a disk and put it on another computer and none of the images loaded up. So obviously today we're going to be talking about actually putting stuff on the internet. So there we are. But yeah, let's talk about last week. We talked about Foundation last week. We also discussed a number of different sorts of boilerplates and static site generators and different sorts of JavaScript, CSS frameworks that'll can speed us along with all that sort of stuff. Basically, it was a class on all of the tools that are already available to you, so you don't have to reinvent the wheel. So, you know, if you haven't done this already, the things that you need to do for this class are install Node.js and install Foundation CLI. And then also for this class specifically, you want to sign up for nearlyfreespeech.net. If you sign up for it before, they might have knowledge that your account once existed, and you might have to pay them 25 cents to or less to be able to re-enable your account. But it is nearly free, and for those who are signing up, it is free because you get a 2-cent free trial, meaning that once you go over the allotted amount of either CPU time or disk space or whatever else, then they'll either shut down your account or charge you for, because you've gone over your free trial. But it's for the sake of this class, 2 cents is just fine. So no need to give them a credit card or fund the account or anything like that. Also, FileZilla client. If you go to FileZilla project, you'll see two download links, one for server and one for client. Download the client, or if you already know how to do SFTP, then just go ahead and use that. Yep. Oh yeah, on macOS, you might get a little warning if you try to open it saying this is an untrusted file. That is okay. This is how you skip that. You just go to the file menu and choose open. Cool. All right. So make sure you set that up as I go through my recap of previous material. So last week, let's see, FWD, Series 10, Class 8, Foundation test. Right. I should actually open up my terminal and do this. So I'm going to do the same thing. Go to FWD, Class 10, sorry, Series 10, Class 8, right. And then go into Foundation test. If you'd like to follow along, as always, all of this material is available online. It's available on GitHub, so you can go ahead and if you weren't able to complete the work from in class last week, then you can just use mine. So just go to GitHub. What am I using? FWD. There we go. GitHub.com/Jeffrey_ATW/FWD. You go ahead and clone this, or download the zip, or do whatever. However you know how to do it, go ahead and get it, and go into Series 10, Class 8, and then Foundation test. If you have Foundation CLI installed, then all you should be able to do from here is just do Foundation watch. So what is Foundation CLI? What is Foundation Watch? Well, Foundation CLI, CLI stands for Command Line Interface, and it is a little tool that allows you to create new sites using the Foundation framework. The cool thing about this little command line interface is that the sites that it generates not only come with all of the JavaScript and CSS bells and whistles that Foundation provides, but it also provides little commands such as Foundation Watch and Foundation Build and Foundation a few other things that aid with the building of a few files that need some preliminary kind of compilation before you can get the final copy, before you can get the actual final result. What I mean by that specifically is we talked a little bit about Sass last week. Sass is a language we'll go into in further detail when we actually start talking about CSS in the class, but it is a language that turns into CSS. So if we take a look at that app.scss, we should see a whole bunch of include stuff, which doesn't look very familiar. We're not really sure what all this include and import stuff does. But I also thought that I put a little rule at the bottom to change things around. But did I change anything in settings? Maybe not. Settings also contains a whole bunch of weird looking stuff that it doesn't look very much like CSS. But both of these files, when combined together, they're essentially just taking a whole bunch of CSS rules from different files and compiling them all into a single thing. So these two files, app.scss and settings.scss, end up turning into just this app.css, which is a very, 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 very long line of CSS. Very, very hard to read, but this is all CSS. You know, dot button group success, space, dot button colon hover, comma, blah, 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 blah. And then background color is this, color is that, you know. So what's going on here is that this little watcher that we're running in our terminal is going ahead and listening for any changes to any of the Sass files inside the Sass folder and compiling them all into a readable CSS file. Well, not readable by us, but a CSS file that is readable by the web browser, because web browsers don't understand SCSS. It's just simply a language that is not and probably will not be supported by web browsers. Yeah, so as long as we have this little task running in our terminal, our Sass will remain up to date. In the meantime, we can also take a look at the other stuff that has been generated or was generated last week. Oh, it's broken. There actually should be a CSS file loading that makes this look a lot fancier, but maybe I changed it just to like demonstrate that you can break things. Let me see here. Looks to me like there's no link tag that links to the CSS file. So why don't we just add that? I must have, maybe I forgot about this. Maybe at the end of class I demonstrated that you can get rid of it. So note, of course, that we are referring to CSS/app.css because app.css isn't in the same folder, it's in a relative folder. We'll be talking a lot about relative folders probably in this class, about, you know, being able to access stuff within child directories. Anyway, there we go, that's what I was looking for. So this is the same thing with all the CSS included. So as you can see, just loading up app.css, which is a CSS file which has been generated from two other files that we didn't write ourselves. This looks a lot nicer all of a sudden. What we added to this thing at the very top was a little item 1 through item 4 list. But this is all just kind of a little kitchen sink page that shows you all of the stuff that Foundation provides for you. The ability to lay things out in a horizontal grid. Nice looking buttons that, you know, even kind of, you know, change color when you hover over them in a nice smooth manner. Little boxes with some places for action buttons. Better looking form inputs than what's built into the browser. And yeah, so, you know, different level headings and things like that. Since I had the time, I might as well just go through the homework. And because that's also another demonstration of what you can do with Foundation. What I had you guys do for the homework was basically do what we did in class. Foundation new to create a new website, and then run Foundation watch, because later down on rule 8, I had you change app.scss, which you know, which will translate into the CSS file as long as you have Foundation watch running. I also had you add a few things to index.html. First, removing everything from there, and then adding in a whole bunch of stuff on your own. So I don't really need to go through it because all it really is just going to this page, finding the things that I bolded, top bar, call out, grid, reveal, and copying and pasting the topmost code snippet into the thing bit by bit. But you know, at the end of the day, what it ended up looking like is, well, this. Let me go ahead and actually, let's see. Solution, week 8. So that's the thing that was generated. And with Foundation Watch, with Foundation Watch running, we went down to the bottom of app.css and added SCSS and added this little CSS rule. You know, Sass is a superset of CSS. That is to say, any CSS that you write is valid Sass. So, you know, if you just want to put a little rule that looks just like CSS in here, which it is, that's fine.
So, what you're saying is Sass is CSS? Or,
Sass is CSS plus a whole bunch of other stuff.
Is it advanced CSS?
It's a superset, yes. Yeah. So, at the end of the day, this is what we got. As you can see, the headings, both here and here are the terrible Comic Sans font because that's the rule that I wrote in my CSS file. But what else did I do? I added a little top bar up here. I just copied and pasted it so it came with this little menu, drop-down menu, search box with a button. I created a call out and changed the heading to an H1. I created a grid with 2 columns, column 1, column 2. And this button, when clicked, opens up a modal. Why is that? Because I asked you to add a data-open example modal 1 to it. What does that mean? Well, Foundation looks throughout the page for a whole bunch of special attributes, starting with data dash and then something. So in the case of data-open, Foundation is going to see that the thing that was just clicked has that attribute, and it's going to go looking for something that has an ID of example modal 1. So here's the modal, and as you can see right here, it has where is that? An ID of example modal 1 right there. So that is the modal that the button causes to open. Yeah, so that's about it. Oh, and here's a little tooltip. This tooltip is pretty simple. All it is a span, and it has, well, these are a whole bunch of weird stuff that Foundation has added to it, but all I added was a data dash tooltip and then a title. What is that title? Am I missing it? Is it not here? Huh, they must have gotten rid of it. What happens with JavaScript libraries is that they're able to read your HTML and then change the HTML around, of course. So what we're seeing here is not exactly what we're seeing in my actual source HTML file. In my HTML file, all we really have is just this little, where is it? Span. And I copied a few things from there, like data-tooltip, aria-has pop-up equals true, class has tip, data disable hover equals false, tab index 1, and then title of front-end framework. Might as well walk through this. Yes?
When you say libraries, I'm still kind of stuck between libraries and what the other thing that libraries mean. Framework. Thank you.
I use the terms interchangeably. A framework, you know, can be considered kind of a larger, more higher touch sort of thing where it's going to where it basically gives you a lot of predetermined features and things that have already been kind of like decided in a certain way. Whereas a library doesn't really make any decisions for you. It just speeds things up for you. It makes it so you don't have to rewrite the simplest stuff that you might want to use everywhere, like what jQuery does. jQuery is a library because it comes with all these little features that speed things up. Whereas a framework like Foundation has decided that that it wants you to have certain behaviors, like a modal that appears this way. It wants your heading to look this way. It wants your colors to look in a certain way. So there's no like sort of place where a library ends and a framework begins. All I can say is a framework is bigger.
I think from like a technical point of view, the distinction is something called inversion of control. So like in frameworks, framework may end up calling code you've written, whereas in a library you call code that has been provided to you.
I don't understand it, but like you said, interchangeable. The framework kind of embodies or it has access to a library to some degree. Right?
Sure.
But a library doesn't have any framework.
Well, again, the terms are kind of interchangeable, but a framework really is something that is larger. So a framework, for example, is a library.
What I want to do is just list all my JavaScript libraries, like Bootstrap, React, Angular, Hard. I want to have that.
I would call all those things you just said more frameworks, but I don't know.
Okay.
You know, I look it up in your own time.
Yeah, okay, sorry.
So yeah, what's going on with this span, for example? What is Foundation looking for when it goes into here? First of all, little data dash thing. This is a tooltip, so that means that anything inside the span is going to be treated like a tooltip according to Foundation. What does that mean? That's just for Foundation to decide what that means. Aria-has popup. I haven't really talked about this yet. I'm not really sure if I will, but there's a series of different attributes that you can apply to elements called accessible rich internet applications, I think, and accessible being the key word. The ability to add additional accessible attributes to specific things throughout your code. Aria label, Aria hidden, Aria has pop-up. These are things that sort of augment the HTML that you have to make it a little bit easier to read by people who need assistive technologies like screen readers or other things like that, or keyboard control or other sort of stuff where they can't necessarily get a full control over what's happening on screen. So where HTML falls short, Aria kind of steps in to pick up the slack. That's an important distinction, though, that HTML is there to do the majority of the work. You don't need to use Aria, you know, just to make things accessible, because a lot of the time, whatever HTML provides is good enough. So, you know, the first rule of Aria is don't use Aria if you don't have to.
It sounds like you're a Spanish carpenter language. So like this when you start trying to make sure you went into your CSS and you try to get it near that set where you see what CSS is
It has nothing to do with CSS. Nope. It's only HTML. It's only about just making sure that certain elements on your page are readable in the correct way. Readable like by a screen reader. And of course, a screen reader doesn't care at all about your CSS because it's for people who can't see.
But you kind of get some kind of style approach to it, aren't you, with Aria?
It has nothing to do with styles. But this does have to do with styles. Class has tip. Essentially, I think that this class is there for stylistic reasons. It's the thing that causes this text to become bold and have a dotted underline. Data disable hover. I guess this means that maybe it's only a tooltip when you click on it. But data disable hover false means that it's not disabling the hover functionality. So I can just hover over it instead of having to click on it. Tab index 1, that might also be a little accessible thing, but it doesn't have to do with Aria specifically. It just basically means that as you press the tab button to go throughout the page, this is going to be number 1 of the things that you can tab through. If you ever try to press tab and things start getting highlighted on the page, that's what tabbing is doing. Funny part is that I'm not really actually seeing this thing getting highlighted at any point, so I'm not really sure if that tab index that it asked me to add in is actually working, which is weird. Anyway, finally, title, a front-end framework. This is something. This is what Foundation uses to actually show up in the little tooltip. Why not something like data-title or data-tooltip-title? Because if this tooltip for some reason did not pop up, what it could do instead. Well, let's say, like for example, I didn't include any JavaScript. I'm going to get rid of this JavaScript really quick. That just commented out. You know, what happens now is that as I hover over it, well, we still get a little tooltip right there. Where did that come from? Well, that is actually built into the browser. Any element on the page that has a title attribute, when you hover over it and just leave your mouse there, a little tooltip will show up. That's something that's built in. So it has nothing to do with JavaScript, nothing to do with Foundation. So it's just kind of a fallback in case the JavaScript doesn't work for some reason. But now you've got this nicer looking tooltip.
Does it have any relationship with developer tools?
No, has nothing to do with developer tools. You don't need to have the developer tools open for that tooltip to appear. Has nothing to do with it. All right, so otherwise, all we really did was just copy and paste stuff, and that was the homework. Yeah, So that's kind of the situation. Oh yeah, and put the call out inside of column. Something I did specifically was this column, this call out, as you can see, does not stretch all the way across the page. It's kind of lined up with the beginning of this column here. And that's because this call out is also inside a column of its own. It's got a div class columns, which is weird. It could be either column or columns according to the documentation, but it's inside a row. The way that grids work, and this is something that I'll probably talk more about when I talk about CSS possibly, is that you've got a row and then you have columns inside it. You shouldn't have a column without a row because things like rows set up the proper, centering of the row on the page. Without the column, it might just stretch all the way across and not be kind of in the right place, or it might be sharing the space with other columns that are next to it, where a row defines like, okay, this is a new row of columns. Anyway, those two things need to work together. So for example, this one these both have a class of columns, and these classes, small, medium, large, define how wide these each should be. That's 6 out of 12 because the way that the grid works, it's got 12 little miniature columns. So since each one of these has 6, that's 50%, 50%, 6 divided by 12, inside a row. So yeah, that's a little grid framework thing that comes with Foundation as well. Yeah, let me see here. Any questions from online? I don't see the little chat window that I had open. Oh, here it is. Nope, no questions. Okay, cool. Yeah, let's see here. I think that's all I really have to cover for previous class. I guess the last thing that I want to do is that there is a command called foundation build. Foundation build is not a very important command as long as you're running foundation watch. What foundation build does is what foundation watch does, but only once. Foundation watch just makes sure that if there are any changes to any of your SAS files, it will rebuild. But this is just basically saying, just running the SAS command to turn it into CSS. But this is actually kind of important since this is the last step that you should take before you take your built thing and then put it somewhere else. Because the idea behind these static site generators is that, well, they generate static sites, but you don't want to edit those finished products. You want to edit the source. You want to edit stuff like SAS files that have a whole bunch of instructions to turn into CSS. In this case, all we really have is plain HTML and plain JavaScript. But there are some circumstances, there are some situations which we'll take a look at later in class where you're not actually writing HTML. You're writing in other languages known as like Jade or EJS or ERB or Haml or other sorts of templating languages that compile into HTML. Same with JavaScript. There's CoffeeScript, there's ECMAScript 6, there's TypeScript. There are a whole bunch of different languages that compile into JavaScript but make it easier to write in some ways. But again, the only languages the browser can understand are HTML, CSS, and JavaScript. And so you need to have this build step that takes all your template languages and turns them into the final thing. And that's what Foundation Build does. Once you've done that command, then you're able to basically take that stuff and put it wherever you want, and that will be the topic of today's class. Yep. Cool. Any other questions, thoughts? Cool.
I'm more interested in being a great debugger before I'm a great builder.
Sorry? You want to learn how to use the debugger?
I'm more interested in being a great debugger before I'm a great builder.
I don't know what that means.
Troubleshooter. Debugging and troubleshooting side thing.
Okay, so you want to fix other people's problems?
No, I want to be able to fix my problem so I'll be able to kind of know what's going to come. I need to know what's next problem.
But that sounds like it's out of order. You need to build it first.
Yeah, I know, but I'm just trying to be slick some kind of way.
Huh?
I'm trying to be slick some kind of way. If I'm a great debugger, to me, I'll be a great builder. That's just that's engineering. It's
one and the same. You can't debug something without building it first. And so you might be really, really good at fixing your own bugs, but you need to create those bugs first. And to do that, you need to build. Right. So I've never heard anyone saying, I'm a really, really great debugger, because all that says to me is that you're not spending your time actually writing code. You're just stepping through it and trying to figure out what you just did. So no, I wouldn't recommend doing that.
I created a bug by accident.
Uh-huh.
You got a couple minutes before we start?
Sure, yeah, I have 5 minutes.
5 minutes?
Yeah.
I was running the foundation watch without any problem.
Yeah.
But the last few times I tried, I started getting a SAS error.
Oh, okay.
Cannot find module supports color. No idea what that means, but it's not allowing me to use foundation anymore.
Interesting. Yeah, so the problem with SAS and a whole bunch of other languages that compile into their target languages is that if you make a mistake in them, then you don't get your target hits, right? So let's see here. Cannot find module supports color. Okay. Within Go auto-briefing.
No idea what it is.
Yeah. Well, first thing that I would do when it's looking for something like that is I would go into the SAS files that we have in your project.
Okay.
Sorry. You go into your folder that has your stuff. Basically, what I want you to do is open up those SAS files and look to see if either one of them has a file is referring to anything called supports color. So just do a Command F through that. I can do the same thing because I probably have the same stuff, right? Supports. Nope, not there. Anything here? Support. Nope. Okay. So no, you won't have that. The next thing is that if it can't find a module, then you might not have run npm install, or you might need to rerun it. Basically, when it can't find that was a node error that you got in your terminal because there was a whole bunch of stuff looking for node modules. And when you have that problem, it's probably due to the fact that your stuff isn't installed properly. So to remedy that, I would try to run npm space install and see if anything comes of that. If you still have the same problem, then I don't know. You have to be able to remember what specifically caused that to happen. Maybe it was the installation of a new version of Node. Maybe some other. Maybe you. I'm not sure. I couldn't tell you. Yeah, no problem. But yeah, if anyone else has had that problem, then let me know because I don't want everyone to run into it. Cool. 2 more minutes, and we'll start with our new stuff.
Let me work. Thank you.
Oh, all right, cool. Good to know. Yeah, I mean, worst case scenario could have been that, well, I'm not sure what had caused it to change, but it just somehow turned out that Node installed all your modules, but one had a dependency on another, which for some reason could not install or did not install, or and you would have to go and trace it, track it down, try to reinstall it manually, or very worst case scenario, go into whatever's trying to ask for it and edit out all of the different code that is trying to use it somehow, which would be terrible, horrible surgery, which I would, wish upon no one. So good thing that it was just something not having been installed for some reason. All right, it is 8. Let's get started. Okay, hi, hello, oops, hi. This is the front-end web development class. Today we're going to be talking about different kinds of file transfer. We're going to start off with HTTP. And so get cozy, because all I'm really going to be doing is talking at you for the next half hour or so about what HTTP is. So HTTP, obviously you've heard the term before. You see it right here, HTTPS. HTTP stands for Hypertext Transfer Protocol. Hypertext Transfer Protocol, it's called that because initially, when it was invented in 1991, the idea, or released in 1991, the idea it was that it was a protocol by which hypertext could be transferred. Ta-da! Basically, it's the way that one computer can communicate to another and ask for different sorts of files, which back in 91, the majority of them were just HTML files, hypertext markup language files. But of course, the internet did not remain so simple. You know, eventually, other files started getting sent over HTTP as well. Images, and then style sheets, and then JavaScript files, and then a whole bunch of different types of media, audio and video, and whatever else. And now, the vast majority of the communication that the browser makes with other computers on the internet to get all the stuff that it needs is done via HTTP. Now, HTTPS, S stands for secure. The idea behind HTTP is that it's really, what you can think about, the good way of thinking about HTTP is that it can be thought of as sort of an email exchange back and forth. But really, like a very, very fast email exchange that happens within a few milliseconds between your computer and other computers on the internet. So it's basically one email being sent out with a request and another email being sent back with the response. And the only thing is that when you send out those sorts of requests, they are unencrypted. That means to say that they're plain text. If you were someone on the same network, for example, if you're connected to the Noisebridge Wi-Fi network, which is unsecured, and you are talking to a website that does not have a little security thing, a little green lock, then somebody on the network can, and very well might be right now, listen for all of the requests that you're making to that thing and be able to not even decode, but just write down, essentially, using their Wi-Fi hardware and software, what you're requesting and the responses that you're getting, because it's completely plain text, unencrypted, being sent just, you know, letter by letter over the internet. And that's just the initial concept of HTTP. Is just I'm sending out a whole bunch of stuff that looks like text, just like an email, and I'm getting back a whole bunch of stuff in return that's just like text. HTTPS encrypts it. It basically creates a little, you know, encryption. It makes it so it's secure. It makes it so other people known as men in the middle. You can't have a man-in-the-middle attack which somehow intercepts or changes or records or takes note of whatever is being sent, because it all seems like gobbledygook, because the only two people that can just decode the message are you and whatever computer you're talking to. So that's HTTPS, secure HTTP. Anyway, when you are downloading stuff from a website, you are, again, the first thing you do is you make a request. And the last thing that happens is that the computer sends that information back to you. But it's really kind of like, I can list it out in multiple steps, and this is kind of the way that I do it. First thing is that your browser, you know, makes a request for a page. Request is sent over the internet to the server. Something happens. 4, the server responds, creates a response. 5, you know, so the browser receives response from you. That's pretty much it. So pretty straightforward. So the browser, I can say, you know, makes or creates a request for a page. The request is sent over. Server creates a response. The browser receives the response from the internet. And really, when I talk about it looking like an email, it really actually does look a lot like an email. What I mean by that is it's got a whole bunch of headers, like the current date, where it's being sent to, what kind of browser it's being sent from, what sort of thing it's making a request for, like what kind of file, and all the response has similar stuff. You know, what type the file is, what time it is on the server, all this other information, as well as the actual body of the response, which is whatever you asked for. Could be HTML, could be CSS, could be JavaScript. But when it all comes down to it, it really is just a two-way kind of communication. So one way that I can kind of check this out is if you want to take a look at the HTTP requests that are being made on your from your browser, then all you have to do is open up your DevTools, go over to the network panel, and keep the network panel open as you load a new page from your address bar. So what's going on with this network stuff? A whole bunch of crazy stuff is going on here. First of all, we've got this really nice little color-coded thing. This is a timeline of all the requests that have been happening on this page since our initial request. So it looks like request, 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 and eventually a whole bunch of other stuff gets sent over. It's still recording 20 seconds later, so I could probably somehow pause this or stop it from making additional requests or something like that. But that's a little timeline of stuff that's happening. This is all network activity. And it's getting smaller and smaller as we go because 36 seconds in, yet another request has been made. But this is another way of looking at it. Each one of these things is another HTTP request that's been sent out for this page. Now that's a lot. Look at all these things. All these little blips right here. Each one of those is a different request. So the New York Times was not loaded with a single request. It was loaded with a whole bunch of requests. Why is that? That sounds kind of inefficient. Why can't you just get the entire website in a single request? In a single response, sorry. The answer is because you're not, with every request, you're only asking for a single file. And the first file you're asking for is just the HTML content of NewYorkTimes.com. Before you get that response, before you get that HTML content, there is no way that you can know what else needs to be loaded. Because the only information your browser has is nytimes.com. And it just sends it out, and that's it. It doesn't know to load up the CSS file for NewYorkTimes.com. Doesn't know to load up the JavaScript file for NewYorkTimes.com. Doesn't know to load up this image and that image and this logo and the styling for all these buttons and all of this weird advertisement and all these images and all this news. Well, the news could come with the HTML file, but all that other stuff it doesn't really know until the HTML file tells the browser to make subsequent requests. The HTML file is essentially a blueprint in more ways than one. It's not only telling the browser of the elements that it should lay out on the page, as you can see here, but it's also listing out all of the other resources that the browser needs to make a request for.
When you said blueprint, it kind of made me think protocol. So some kind of protocol is in that blueprint, or is it protocol?
Well, I wouldn't call it that. No, I would say that it's not a protocol so much as it's just HTML. What we've got here is a request and a response for NewYorkTimes.com. And what we're getting in response is HTML. As you can see, all these tags are HTML. And what the browser does is goes through these sorts of things, looks for different elements, and sees what sort of stuff it needs to download. For example, here on line 48, it sees a link rel style sheet. We've seen that before. That's us adding a style sheet into a page. And it's also got an href. So by the time the browser reads through this HTML file and reaches line 48, it knows that it is now time to make a request for this URL, http assets.newyorktimes.com, blah, 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 styles.css. So, it's not so much a protocol. I don't really know if that's the right term to use here, as much as it is just like a list of instructions for the browser to read out and execute on, So another good way of looking at this is, let me skip these two things first, these WebSocket New York Times stuff, start here. As you can see, styles.css is the second thing that's been requested. And you can also see that there's an initiator column, index:48. Remember I said line 48 is where the CSS file is being listed out? If I go down here to line 48. So we can see that the reason that this styles.css request was made in the first place is because of whatever was on the main page, line 48. So there we go. This is our first request. This is our second request. But let's jump a little further into this request for NewYorkTimes.com. you'll see that, that there's a whole bunch of information that's being sent over to the server, and then a whole bunch of stuff that's being sent back. Let's close these response headers for now. These request headers are, it looks like this. This is essentially what the behind-the-scenes body of the email looks like. I say email, but it really is an HTTP request, but it looks in a lot of ways like the body of the email, because it's got this equals that, this equals that, this equals that. Starts out with get HTTP. We're making an HTTP GET request. We'll talk about GET requests in a second. We're sending it to NewYorkTimes.com. I don't know what this means. I don't know what this means. User agent. Basically, what my browser is sending over is an identifier saying, hi, I am Mozilla 5.0 on a Macintosh, Intel Mac OS 1012, using Apple WebKit 537, Conqueror HTML like Gecko, on Chrome version 52, and also for some reason Safari version 537. That identifier is very strange. There's a lot of reasons why that whole thing has a lot of weird names in it, like Mozilla, even though this is Chrome. This is not Mozilla Firefox. It's also sending information like what kind of stuff it accepts in return. We've made a request out to NewYorkTimes.com, and we would like to accept back something with a type of text/HTML. That means we don't necessarily want you to return me CSS or images or whatever else. When I access NewYorkTimes.com, I accept text/HTML, but if I don't get it, then I'm okay with application/XHTML, which is something like it. Or, oh, the page just reloaded itself. That's nice. The page probably reloaded itself because it was on a timer and it went ahead and did that again. But let me read this. If not XHTML, then just XML, which is another thing. I don't know what this means. I can also accept an image of type WebP, and if none of that works, then I'll just take anything. */* means if you don't have an HTML file for me, you don't have an image for me, you don't have whatever else, just give me anything and I'll accept it. You got a question?
Yeah, to me that was like Mozilla, Safari,
Yes.
what operator? It's like all of the 5 major.
Yeah, I'll get back to the user agent in a second. It's confusing, but it's weird. DNT, do not track. That's essentially me telling this New York Times thing, try not to supply me with any advertisements that might be tracking my behavior on the internet. It's kind of a weird, nebulous sort of thing, and it doesn't really amount to much. Refer, NewYorkTimes.com. Remember the page reloaded. Refer, misspelled, is whatever page referred me to the current page that I'm on. So since the page reloaded itself, it was NewYorkTimes.com. Yeah?
Is the DNT taking binary value?
Yes, it's 1 or 0, I think.
So did you, I guess the headers, they don't accept booleans, they just return binary?
I mean, this is all just text. So, like, you know, this is exactly what's being sent to the server. It's not sending things of a certain data type. It's just sending text. So, you know, DNT, nowhere, yes, it could be that, but I'm pretty sure that servers configured to accept or, you know, or actually listen for a DNT header are looking for either 1 or 0. Yeah. Accept encoding. This is saying if you want to send me back stuff that is zipped up in a certain way, that is compressed, then I can accept these different kinds of encodings. Accept language. That is literally what human language I should expect this thing to be in. If you've ever been to a different country and loaded up a site that you're very familiar with, but it's been in a different language, that's probably due to this header being sent over to the site. It's saying, hi, the browser that I'm using, it's by default asking for stuff in Spanish or Italian or Japanese or whatever. In this case, I'm saying ENUS, English, US, you know, so send me that. Yeah.
Okay, so you can change it from that point.
If I wanted to reconfigure my browser to default to a different language, then it would send a different header when I made the request. That doesn't necessarily mean that the server is going to respond with the proper stuff. Only certain websites that are set up to support international visitors will listen for this accept language header and change around what they respond with. So you can't guarantee that what you're going to get back is going to be in the language that you asked for. Yeah.
Is there a list of those servers that you can access for the issue?
Nope. There's not a list of servers that accept this because it's changing constantly all the time. Cookie. You might have heard of cookies before. And oh, this site might do cookies to your computer. Oh no. There's actually a really stupid law in Europe that where every website that makes use of cookies needs to notify you that it is going to make use of cookies, which is really stupid because I would say 99% of websites out there use cookies in a certain way. But what are cookies? A cookie is a very weird term for a way that your computer can identify itself uniquely to the computer that to the server that you're talking with. What's happening is that if you've been to the server before, then what the server has sent back to you is potentially a header that says set cookie. Set cookie is essentially an instruction to your browser that it will receive as part of the response coming back from the HTTP response saying, hey, set up some new stuff as part of your cookie. You store some stuff for NewYorkTimes.com that is this. What is this? What does this mean? It varies from host to host. This is something that you don't really have to care about. It's just something that the server, in this case NewYorkTimes.com, cares about to be able to somehow identify you or store some information that is unique to your visit to the website. So every time that you come back to the site, you're going to be sending back a request header with this cookie, which is a whole bunch of information. And if you read it fast enough, you'll be able to possibly impersonate me because this is uniquely identifiable information about me. Fortunately, I'm not a member of the New York Times. Oh, actually, I am logged in. Whoops. So yeah, don't screen cap this and try to impersonate me because that is possible with all this information here. Oh yeah, and oh yeah, let me change this to view source to make it a little bit back to what I was showing here. Large cookie, and that's pretty much it. So that's all the information that I send over to the New York Times or to any website every single time that I make a request for something. Of course, the cookie will change based on the server that I'm talking to. This is only, basically my browser has this information already here for NewYorkTimes.com. So it's only going to send this information when I access NewYorkTimes.com. But there's a whole bunch of other cookie storage for other websites out there that my browser knows about. And so it'll send that information along again, saying, here I am again. That is the way that your browser that is the way that services, any service that you log into, Gmail, Google in general, Facebook, Twitter, any sort of service out there is able to identify you without you having to log in again the next time you access the page, or every time you access any page. The cookie is one of a few things that makes it possible for you to be able to send over a unique identifier that the server knows about, saying, "Oh, here you are," and it's better. Oh, the New York Times reloaded itself again, but it's better than a password because passwords should never be sent over in the clear, and having to send a password over to a site every single time you access any page is somewhat dangerous. Yeah.
The cookie sounds like it's kind of like a prejudice or preconceived. It's already kind of pre-labeled for you. So it's already kind of your introduction, your announcement.
Yeah. It's a way that a website can tell your browser to introduce itself the next time you come to the site. So yes, it is a preconception, if you will, of what you've done before. And you can clear cookies too. You can go to like tools, clear browsing data, and that'll clear out your cookies, which means that the next time you access the site, it'll be as if we won't send any cookies, and so it will be as if the site's never seen you before. Although there are a few other ways that a server can identify you. One of the specific ways is via your IP address. Every every computer that's on the internet has a specific IP address. You've probably seen it. You can ask, what is my IP address? If anyone Googles this right now, you're probably going to get the exact same thing that I am, at least everyone in this class is, because that is the IP address for Noisebridge. Everybody's connected with a local IP address that's different, but you're all connected to that little thing on the ceiling there, which is connected to the main router at Noisebridge, which has the IP address of 192.195.83.130. So this is one way that no matter what you're using on the internet, people can identify you by this. This is the reason that some people use the Onion router, Tor, or other sorts of things or other sorts of virtual private networks, VPNs, to mask their communication online and make it so it looks like you're coming from some weird place out in Eastern Europe or something. So that's one way that you can kind of hide yourself, but this is one way that people will identify you, even if you are using, even if you have cleared your cookies. That said, every computer within this whole building has that public IP address, and so that's not a way that a website can personally identify your computer. Maybe a better way of identifying it is seeing, is the user agent the same? Like, in addition to the IP address that's just sent out as a matter of your computer communicating with stuff on the internet, your user agent is sent over, this thing here, and this isn't uniquely identifying to your specific computer, because someone else could be using a Macintosh running Intel Mac OS 1012 with Chrome 52.02.74.3116. There could be someone else running that exact same thing. So it's still not a perfect way of uniquely identifying, but it's another way that websites can see who you are, or at least what you're like, to be able to cater a specific experience to you. You got another question?
Yeah, it sounds like this is an experience, but let's say Google will do by chance advertising to you. It's kind of like they know your history. Is the cookies in that same thing, that theory, the same thing?
Yeah, without cookies, Google wouldn't be able to uniquely identify you, and they'd only be able to cater advertisements to you based on your IP address location or what kind of computer you're using. So without that unique identifier that's sent over via cookies, then Google doesn't know who you are. So they can't cater advertisements or other sorts of things too. Of course, you also can't log in. So take it, yeah.
How do requests work when it comes to incognito windows and cookies?
Good question. HTTP requests and responses are still sent via incognito, but let's take a look at how things are different. Let me reload this again and ask for NewYorkTimes.com. All right, so let's take a look at my request headers. Interestingly enough, there is a cookie there. It's probably because I reloaded this page, and so the very first time I access this set cookie, let me try this again. All right, fresh incognito window, inspect element, everything's been cleared. I'm gonna go to NewYorkTimes.com, and I should not expect that any cookies have been set. So if I take a look at my request headers, oh, there's still something. Where did that come from? Response headers.
Even if you do a hard reload?
Well, every time I open up incognito, it's essentially the same as doing a hard reload. So, yeah, I don't really know where this is coming from. Optimizely, blah, blah, blah. Hard reload. No, I mean, hard reload doesn't clear your cookies, because if it did, then that means every time you did a hard reload, you'd be logged out, which you don't want to do. So, no, I don't really know what's going on, but essentially it's smaller. I am sending less information. And there is no way for the New York Times to know that I'm using incognito, which is the way that I use the New York Times without actually paying for it. Because if I access this article here, it's probably going to say, sorry, you've read too many articles today. So all I do is just copy this HTML thing here, open it up in incognito, and given that I'm sending a unique cookie that is not tied to the fact that I've visited the site 10 times, it has no way of otherwise tracking me. The only information it has is what my IP address is, what my user agent is, and no other way to confirm that I am indeed the person who just received that notification that I've run out of free articles for the month. So that is unfortunate for the New York Times.
How does that work? You have a new cookie in incognito?
Yeah, in incognito, I start off with no cookies. So the first time I make a request for the site, I'm sending a blank cookie. And subsequent times, all it's doing is saying, well, I don't know who you are, but here, take this cookie. And as long as this thing is open, you can access 10 articles, and eventually it'll be like, well, you've just accessed 10 articles. So all I'll do is I'll close the window, open it up again, and it's like, well, I've never seen you before, so here you go.
So whereas in normal Windows, all instances of the New York Times would just be tied to the same cookie?
Yeah.
Crazy.
Yeah, I'm not sure 100% if clearing cookies is good enough for the New York Times to be unable to identify me outside of incognito mode. There are other sorts of things like local storage, web storage, and IndexedDB, and other sorts of other identifiable stuff nowadays that are other ways of identifying yourself. But possibly clearing cookies will reset that count. So But then again, I like the New York Times, so pay for them if you read them a lot. Okay, anyway. What is FTP? Okay, Death to Islam. Great name. Great name. Yeah, that's a pretty terrible thing to say. Yeah, if one goes, all should go, right? Death to atheism, too. So, you've got a really bad name, but I'll talk about FTP in a second. Okay, anyway. Cool. So, where was I? Right. So we were talking about this whole step thing here, about how we create a request, and the server creates a response, and we receive that response. And based on the response we receive, you can oops, sorry. Well, these are all not actual. These are local requests for different things. Based on the requests you receive, you might make additional requests. So the reason that all this stuff is loading up here is because there must be somewhere within either the HTML or the JavaScript, or the JavaScript that was loaded more HTML, that loaded more JavaScript, that loaded more HTML. Somewhere along the line, there was the instruction that your computer should make yet another request to download some additional stuff. So it's really just a big chain that starts from the first request up here at the top. For some reason, at the very, very top of my thing, I've got a WebSocket request for something with a switching protocols thing. WebSockets are a different way that your browser can communicate with the internet that doesn't have to do with HTTP. It's a different kind of communication where instead of this like request response, back and forth thing, what you're doing is you are you're basically like picking up the phone from the receiver and keeping it open and just like maintaining a constant connection with the server, being able to listen for additional stuff down the line. Additional messages, stuff like that. It's essentially a long pull, a long listening for any other sort of information that your stuff might be sending down there. So it must be that for some reason, every time that I open up the New York Times, not only am I asking for the HTTP version, but also the WebSocket version. That's weird black magic to me, but there are other ways nowadays that you can talk with servers that are not necessarily this back and forth HTTP communication.
It's running that instantaneously updated doc index. Is that what the WebSocket is?
That very well could be it. This information might be sent over via WebSockets. Information where you need like an immediate response, or you might need to have like very, very fast information streaming down like very constantly. HTTP isn't necessarily the best venue for that because every time that's happening, your computer has to make a request, send all that header information, get all the response information back, and parse it all out. Whereas something slimmer like a WebSocket request is essentially, see this timeline? You see this really, really long blue bar? That is the timeline. That is to say, for 1.7 minutes and beyond now, this WebSocket request or WebSocket connection has been open and information has been sent back and forth. The time is pending, meaning that this WebSocket connection is open and it might be receiving additional stuff. But this requires that the server is configured a certain way to be able to broadcast information out to every WebSocket client that is connected to them. So it's a little bit more complicated because there's this now two-way initiation where not only you can initiate a request and get a response, but once you make that connection, then the server can keep sending stuff back to you whenever it wants. So that's great in a lot of cases. That solves the whole problem of like having to listen. Is anything new now? Anything new now? Anything new now? Anything new now? No, I'm just gonna take my phone off the receiver and keep it on, and then just receive information whenever it comes down. That's cool, but that's outside of the realm of this class and probably outside of the realm of this entire series of classes.
Sounds like you can kind of select what you want to be listening to somewhere in there.
Say that again?
Well, if I want to just listen to a certain type of information, can I do that as well? And that's kind of advanced.
I don't know what you mean by a certain kind of information.
Like if you kind of stream it, can you have like protocol, some kind of thing measures to kind of catch certain updates or whatever?
I'm sorry, you just said a lot of things.
Can you decide what WebSocket you listen to?
Yeah.
What WebSocket you listen to? No. So based on the information you're getting from the server, your browser is going to run the different JavaScript and whatever that results in your browser then making requests out for a WebSocket connection or whatever else. I mean, you know, this is the way the browsers work. They receive HTML, CSS, and JavaScript from different places, and they go ahead and run it. So can you decide what you want to see? Well, of course, you can decide what websites you go to. But what those websites send to your computer and then have your computer do, well, that's based on whatever you're downloading to your computer. So
you can't interact with that information before it gets to you in some kind of quick fashion.
No, not really. No. I mean, you can create your own browser that deals with that information however you want, but no. By default, Chrome just downloads stuff and already probably has some JavaScript that's already loaded up on the page to deal with that information. So, you know, it's not like an interactive user, you know, session thing. It's just something that's happening in the background. So anyway, a few other things that I should talk about with HTTP is that when you make a request and you get a response, that response might have a few different results. What I mean by that is you might get different status codes. So right here, I've got a status code for NewYorkTimes.com of 301 moved permanently. What I did was I made a request for http://nytimes.com. And what I got in response from the server is an HTTP response that, well, let me see if I can uncache this and get the actual response and take a look at it. Oh, sorry, 1 second. Let me try this again. Okay, so up here at the top, I'm making a request for nytimes.com, and I get a response at the very, very top of the response. It returns, here's an HTTP response, 301 moved permanently. So what does that mean? That means that it is a code to be sent back to the browser telling me that I should treat the response a certain way. The 301 code basically means that the thing that I asked for, don't ask for it again. It is somewhere else. You should ask for that thing elsewhere. What should you ask for instead of http NewYorkTimes.com? Well, according to the response headers, there's a location header that says the actual location of what you're looking for is www.nytimes.com. So the reason why sometimes you go to a website after just typing in google.com and end up at www.google.com is because the server is configured to send you a 301 response saying this is where you should actually ask, what you actually should ask for. So from then on, your browser has the information that whenever you type in nytimes.com or google.com again, it's going to completely skip that first request and go to the place that it's specified that it's moved permanently to. So yeah, unless you clear your cache or do a hard reload or something, it's not going to make that initial request again. Which is why outside of my WebSocket thing, outside of my incognito window, you might have seen that it said 301 moved permanently from cache. Your cache is part of your browser that stores files that might have already been downloaded or requests that or responses that it might have already been received. So, you know, if I, again, go to just nytimes.com, and you'll see at the very top, there is a 301 moved permanently, but I didn't actually make the request. This network communication didn't actually happen. This is just my browser knowing that making a request for nytimes.com should really make a request for www.nytimes.com. So there you go. And then finally I get this and it's like, okay, good. You asked for it, you got it. Great. There are also some cases where the request gets forwarded multiple times, like google.com is going to send me to https www.google.com, but not before first trying to redirect me from google.com to www.google.com, and then www.google.com trying to redirect me to HTTPS with a 307 internal redirect, which is some other sort of weird thing, which I'm not going to talk about. And then finally, I get HTTPS www.google.com. So Google is trying to enforce, oh, you tried to talk to me via plain HTTPS, unencrypted, whatever else. I don't go for that, so I'm going to redirect you to the HTTPS version, which is what every site that deals with your login credentials should do to prevent man-in-the-middle attacks. Good question?
So this is www has to happen.
No, it doesn't.
Oh.
www is just a stylistic thing that some people like to do with their websites. I'm not really sure. Maybe some people may think it looks better or looks a little bit more like a real domain name or something. I don't really know why Google wants www.google.com. I would really chalk it up to their branding. That's just what they want their URL to look like. But you know, unless the server is misconfigured in some weird way, most sites should act such that if you ask for blank something.com, that either it shows you the www version or just skips right past it. You know, like noisebridge.net. Actually, I think they have it opposite, where noisebridge.net keeps that way. But if you go to www.noisebridge.net, then it takes you back to noisebridge.net. So it's really the choice of whoever's configured the server to either redirect you to www or redirect www to root. You know, whatever. Either way. So yeah, the whole www dot thing does not really mean anything, and it really never did. There might have been some really old servers that were only able to serve World Wide Web pages via that because they expected that you'd be accessing other stuff via like file transfer protocol, ftp.something.com or gopher.something.com or other sorts of weird protocols that no one uses anymore. But yeah, nowadays just so-and-so.net is good enough, or .com. You know.
So it's generally good web design to have that.
You need to have a www?
To have a redirect.
Well, it is good. It is good web development practice to not serve at both. The biggest reason for that is for search ranking. You know, my sister can go into this in great detail since she's an SEO director, marketer, whatever. What she talks about with search engine optimization is that if it turns out that your site can be accessed from anything.yoursite.com, that's bad. Because Google says, oh, you actually have duplicate content. You have it here, 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 and here. I'm treating them all like different websites, and you must be doing some sort of weird copying or plagiarism thing because I see this exact page duplicated everywhere, and that's what spam pages do. That's what actual phishing sites do. They make something that looks the same all over the entire internet, and so Google could misinterpret that to mean that you're actually trying to do it yourself and trying to get away with it. So setting up a redirect to a single canonical page is good practice. It's up to you whether it's www or not, but I would choose one and stick with it. You know, yeah. There are actually some services that do something weird. Like if I go to ico.us, it brings me to del.eco.us. Delicious. You know, so del is necessary, or it will 301 redirect me from there. See, 301 move permanently to del, right? So same thing. It's just vanity URL funny stuff. So what are all these HTTP status codes? What else is there besides 301? Well, I'm sure one that you probably all heard of is 404, file not found. 404 is the response that you get from a server when the thing you asked for could not be found. Now, this is different than you being disconnected from the internet or being unable to talk to the server. Being unable to talk to the server, you're not going to get an HTTP response back. You're not going to get a status code. You're not going to get anything. You're simply just going to get no response whatsoever. So you'll probably see a message saying something like this: the site can't be reached. This is Google Chrome's error message saying, I tried to make a request to this.com and it did not exist. So I try this, and let me try that again. And it doesn't even show me the response that the request that I tried to make. It just showed me these images that loaded up on the error page. So I can't even show you what it tried to request because it's not there. But yeah, so a 404 means that you were able to talk to the server, that the server did send a response back to you. The response might have even had some HTML in it, and that HTML might have actually had links to images which could load. When you make a request for a certain thing, then you're going to get something like a 404 error. And as you can see, this has JavaScript, CSS, HTML, a cool little effect when you move your mouse around. That's cute. But I take a look at the network panel, and here we go, 404 not found. So it's still a response, and it's still got HTML in the response, but the difference is that I've got a different status code. So that's essentially a signal to the browser that it shouldn't, it shouldn't continue trying to talk to that page again. That maybe the next time you make a request for that, it's not there or something. I'm not sure if that is necessarily a message that the browser should stop trying the next time you make a request, but could be taken that way. So there's a whole bunch of other ones. Let's take a look at all of them. So 100, continue. 101, switching protocols. We saw this when we tried to make a WebSocket request. 200, OK. 200 OK is the most common HTTP response, hopefully. That is what happens when you access a website and you get the content back. That is when the little green circle shows up. Look, see? 200, 200, 200, 200, 200, right? These are all 200 requests, meaning here's the stuff you asked for. 201 created is what happens when you send a request to create something new on a server, like a new Facebook post, a new blog post, upload a new photo, something like that. That is the creation step. Usually, not necessarily, but most of the time, you'll get a 201 response back from the server. 202 accepted means you sent information and you didn't get anything in response, but the stuff you asked for was accepted. 204, no content, similar thing. You made a request to maybe delete something delete your photo, delete your blog post. You get a response back saying, I did it, but there's nothing to show for it because it's gone, right? So 204, no content. 206, partial content, that's not very common, but that's when you might get things in multiple responses for some weird reason. I've never heard of multi-status, but it's a nice, cute cat. 300, multiple choices, that's also something I don't see very often. 301, move permanently, we just talked about that. 302, found is also very common. 302 found is when you make a request for something and you're being redirected somewhere else, but the next time you asked for it, you should ask for it again. It's essentially, instead of saying, never ask for this again, it's saying, ask for it next time, and I might send you a 200, or I might send you somewhere else. It's been found or moved temporarily somewhere else. Never heard of 303, see other. 304, not modified. 304, not modified is server-side caching. What that means is, oh, you've made a response for this before, but based on the headers that were sent back, the cache headers that were sent back, things haven't changed since the last time you asked for it. I know you asked for it because you sent me a little header saying, hey, I've been here before. So you already have it in your cache somewhere on your file system that your browser has stored, and nothing's changed. So I'm not going to give it to you again. Just use the version you have. That's what 304 not modified means. So that's great. It's just kind of trying to speed things up from an efficiency standpoint. 305, use proxy. I guess you have to use a proxy. Temporary redirect. That, we've seen a few of those already. That's what happens when your personal browser, when your local browser already knows where to go for a certain amount of time. I guess I'm not 100% sure. So what I should note so far is that the status codes start with either 1, 2, 3, 4, or 5. So far we've seen 1, which is like, okay, we're not done with this yet. It's time to continue on to the next thing. 2 means success. Anything starting with the 200 something means that the request you made succeeded. 3 means the request you made succeeded, but there's something else you need to do. You're being redirected somewhere else. You need to ask for something more. 400 means you made a mistake. You, the browser, did something wrong. You sent me information that I couldn't parse properly or that I couldn't handle, bad request. You sent me some information, you made a request for something that you don't have access to, or you need to pay for it. I don't think payment required ever really was implemented properly, but there was this idea where every time you accessed a resource, you'd have to send some sort of evidence that you have paid for it, which is interesting. 403 forbidden is like unauthorized. but it means that you might be logged in, but you don't have access as, maybe you're not an administrator, you're only a user. So you only have access, even despite the fact that you're logged in, you don't have access to it. 404 not found, the thing that you asked for is not available on the server. The server is not configured to find the thing that you're looking for. 405, method not allowed. Method, I haven't talked about methods, but I might as well do it right now. You might have noticed in addition to 301, 200, blah, 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 that I've also made, oh, it's not even being shown. Where is it? Type, protocol, remote address, scheme, server, method, there we go. I'm not sure if this was hidden for you guys, but method, get. These are all get requests. Let's talk about get and post requests. A get request is when you type something into a browser, when you type something into the address bar and press enter. That's a get request. A get request is when you click on a link on a page. That's a get request. A get request is when you're loading up an image, you're loading up a CSS file, you're loading up a JavaScript file from within your HTML file. That's all get requests. Your server is simply trying to get some sort of resource on the server. But there are other kinds of methods, such as a post request, or a put request, or a patch request, or a delete request. There are a few other different kinds of HTTP requests that, or request methods that are sent when you're trying to modify stuff on the server. What I mean by that is that a post request is sent from your browser when you are trying to create something new on the server. That is to say, when you're trying to submit a form that has like a new blog post, new Facebook, Twitter post, new photo, new something like that. That is the creation of a new thing, and then you send a post request with that. You can send a patch request to update something that already exists. You can send a delete request, obviously, to delete whatever the resource is online. Now, do these look different? Do these HTTP requests look significantly different? Not really. At the very top of your request header, instead of get up here, you're going to see some other word like put or post or patch or update or delete or whatever else. And the server might be able to handle that method differently based on the thing that you send it. You know, there are some sites that are configured such that like the URL is very clean, like users/1. And if you say like users/1 and you send a patch request to that, then you're trying to update that user. If you send a delete request to that, you're trying to delete that user. If you send a post request to that, well, that's not really possible because the user is already created, but whatever. So even though it's the same URL, the same address in the address bar, depending on the different kind of request method that you send, different things might happen on the server and you might get a different response. So that's something to be known about. So George W. Bush eating a cat, that is kind of a request method that's not allowed based on the resource that you asked for. Not acceptable? I don't really know. I think that probably means that somehow your headers had some information that was wrong or that it couldn't understand. Request timeout probably meant that your headers took too long to send over. That you were trying to communicate with the server blah, 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 blah. The server got bored of trying to receive all your information and said request timeout. That's what happens when possibly your internet connection or your computer is extremely slow for some very strange reason. But HTTP has been around for so long, and it takes just a few milliseconds for all this stuff to happen. So something must be really wrong for there to be a request timeout. Yes?
What determines the length that after which it's a request timeout? Is that there's just like a global standard for how long?
Not really, no. Every server is configured differently to time out after a certain amount. There might be some sort of like stock variable that comes with, or value that comes with certain web servers like Apache or Nginx or whatever, but but there is no specific. I mean, maybe there's something in the HTTP spec saying like after a certain amount of time you should, but I don't think so. And I'm certain that it can be configured on a per server basis. 409 conflict. That might happen when you try to post something that's already there. Like I said, user/1. You try to send a post request and you can't because user already exists. Request URI too long. That's what happens when your actual uniform resource locator or your uniform resource indicator, or this URL at the very top of the screen, is too long. Some servers will go like, oh my god, you just tried to send me something that was like the size of War and Peace, but it was just the URL up there. That's not going to fly. So it's going to say, sorry, you can't do it. Gone. Gone is like not found, but it means that something might have once been there, but it is no longer there. That is essentially what some web services will do when they have shut down, and the content, it's not like it's not found, it's that it was there, but you can't access it anymore. So something like GeoCities, for example, well, what they do now is they redirect you to a place where you can sign up for their new service or whatever, but GeoCities was a web host where you could put up little sites and everything, very popular back in the 90s. And for a while, when you went to certain places, you got a 410 response saying, not there anymore, gone. Length required means that as part of your header, you must request what file size you're looking for. That's a weird thing. Request entity too large. That's kind of like request URI too long. But request entity basically means that everything that you requested here, request headers, blah, 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 that this might have been too big. What else do we have? Requested range not satisfiable. I don't really know. Expectation failed. I'm a teapot. I'm a teapot was an April Fool's joke put on, which was created as like a request for comment in RFC, submitted to the HTTP standards board or whatever, and they decided to actually implement it. So when you make a request for google.com/teapot, you get a response saying 418, I'm a teapot, saying the requested entity body is short and stout. So yeah, that is an actual HTTP response that you can get from a server, which is silly. Unprocessable entity, I don't really know. That means probably something you sent as part of your headers weren't correct. Locked, I don't know. I don't know what those mean either. Upgrade required. Maybe you're making a request from an old operating system or an old browser and you can't, whatever. Too many requests means that you've been hitting the server too much and it's trying to say, sorry, can't do it anymore. I'm getting DDoSed by you or something, so can't do it. More stuff, no response, blocked by Windows parental controls. That's a funny one. And then finally the 500s. 500 is different than 400. It's still errors, but it's the fault not of you, but it's the fault of the server. 500 is what happens when a server is misconfigured. When a bug happens, when some sort of error occurs in trying to fulfill your request, and the server just can't do it, and so it's sending you back a 500. Something wrong happened. 502 and 503 essentially means that the server has been turned off, or that, well, if the server's turned off, you don't get any response. But it could be that whatever the server is trying to communicate with on the back end can't access it. It might be that the server that you're talking to is trying to do something in step 3, or it's trying to communicate with some other server that might be turned off, or something like that. And you might get a 502 or a 503 in response because you can't access it. I don't know what these mean. Insufficient storage probably means that you're trying to upload something to the server, but it's run out of space. You know, run out of disk space. Loop detected. Loop detected probably happens when the server tries to redirect you somewhere, but then you make another request, and then it redirects you somewhere else. You make another request, then the requests go back and forth because you're in 301 loop hell, and eventually it says, sorry, I'm going to stop you here because I must have accidentally redirected you to the same thing a million times. So a loop's been detected. Bandwidth limit exceeded was what happens when a website has run out of money. A website, when you run a host, when you pay for a host, you have a certain amount of bandwidth. That's the amount of communication that your server can make with its clients. And once you go over that limit, your server might start sending this message out saying, sorry, the person running the website didn't pay for as much bandwidth as they needed. Network connect timeout error, that probably just means that in the backend somewhere it tried to do some local connection with something and had problems. Unavailable for legal reasons, precondition failed, and unsupported media type, and gateway timeout. So yeah, a whole bunch of different response codes. And the reason I went through that whole list is because cats are cute, and also because it gives you probably a little better idea of things that can go wrong when you are trying to access a site, and all the sort of little conditions that sites can sort of program themselves into. Yeah. So why is this question mark thing here? Why am I leaving this as a question mark? Because that's outside of the scope of front-end web development. What happens right here is back-end web development. What happens there is anything and everything that could ever happen. Because once you make a request to a server, that server is capable of doing anything. You could access a specific resource, and that server can go ahead and say, oh, that's the resource to go launch ICBMs. Okay, great. The world has exploded. Like you can do anything, really. Like it is a computer that can run code, and so anything goes, and that is back-end web development. But once it's done, the expectation is that the server is going, if the world hasn't exploded, it's going to send back a response, an HTTP response, and that's where the browser comes back in and actually has to know about this sort of stuff. So I would say that at step 3 is where you reach the boundary of front end and veer into back end territory. So that's why I kind of leave that blank for this case, because really, seriously, the idea is that anything can happen. But what happens most of the time? Well, I'm not even sure if the term is most of the time, but what is the simplest thing that happens? The simplest thing that happens is that the server looks for a certain file and sends it to you. That's what servers by default are set up to do. There's a specific folder on the server somewhere that's got a lot of files in it, and the server matches those files to different URLs and says, oh, you asked for this at this URL? Here you go. So that is not necessarily what a server has to do. Servers are not in the business of sending files to you. They are in the business of sending responses to you. And those response bodies could be anything, but they're not necessarily individual files per se. They're really just a whole bunch of text, right? So, but that said, we're going to go ahead and sign up for a service where, by default, its own server that you're going to be dealing with is set up to send files back to you based on what you request. So if you have signed up for nearlyfreespeech.net, this is the point at which you're going to log in at nearlyfreespeech.net. If you haven't, then just go ahead and sign up now. It takes like a minute. You just enter in some information, and there you go. No credit card or payment required whatsoever. So you just log in. And once you are logged in, then you are going to want to create a new site. So you can either just click Create a New Site right here on the right column, or you can go over here and press this Create a New Site button from within the Sites tab. And you want to enter in a short name. The short name could also be your username if you're only planning on making a single site. Really, it does not matter. Just enter in your username. That's what I'm going to do. So that's the site this is the host that it's going to make. For me, it's going to be jeffreyhw.nfshost.com. For you, it'll be whatever site name you choose, .nfshost.com. If you want to have another name, say, no, we're not going to use another name for now. This is in case you want to have nearlyfreespeech.net's web hosting linked up with a domain that you buy on your own. We're not going to do that right now. Let's see. What do we want to choose? Just keep this as is. This is the point at which you can determine what kind of server you want your website to be running off of. But we're just going to stick with the basics. PHP, CGI, that's fine. Here's what will be set up. Your new site will be this. My account will be this. My site will be attached to this account. I'll be able to access it here, and then create now. All right, my site has been created. So I'm going to go click here to continue. And now within the Sites tab, I've got site information for jeffreyhw. If I go ahead and click on jeffreyhw.nfshost.com, it brings me to jeffreyhw.nfshost.com. This is something that all of you can access right now. In other words, we are actually on the internet, and I've just created a little site. Of course, the site has an HTML page with a 403 forbidden because what's happening is that you're asking for index.html on jeffrey.nfshost.com, and you, the person who's trying to access it, doesn't have access to it. So the first thing you get is a 403 forbidden response with this HTML. Sign-on may not be set up. Directory may not have an index. You may not be able to access it. Yeah.
Did you cover 404?
Yes, I did. Yeah, it means not found.
Okay.
So yeah. Okay. Once you got this, then the next thing that I want you to be able to do is connect to it. The way that this is going to work is that we are going to establish communication with this server, but not via our web browser. We are going to use a different program that can communicate to our web server not via HTTP, but via FTP. FTP, which this guy with a terrible username was asking for, was what is called File Transfer Protocol. People don't use File Transfer Protocol anymore. They use Secure File Transfer Protocol, which is just like HTTPS. It's FTP, File Transfer Protocol, but secure, SFTP, secure. And so here's the information to be able to connect to it. I'm going to use my password. This is the username I'm going to connect with. And this is the host to which I'm going to connect. But again, I'm not going to use my browser. I recommended that you install FileZilla. FileZilla is an SFTP program. It allows you to have an easy drag and drop interface from your local computer to the remote computer you're connected to. Just drag and drop files, very simple. So I'm going to go ahead and click this little button up here to open up the site manager up here in the upper left. And now I'm going to be able to set up a site. I've already done this in the past, so this is the information that I need here. Make sure that your stuff looks like this. Change your username to whatever is listed exactly right here. Paste that in there. Change your logon type to normal to be able to do that, and then enter in the password that you signed up with at nearlyfreespeech.net. It might, if you haven't changed your password, then it's whatever you received via, from your email as your initial password. I recommend changing that. The protocol is going to be SFTP, not FTP, and the port can remain blank. But the host is ssh.phx. It's going to be right here. Just go ahead and copy this and paste it right into your host. That's all the information you need. Still seeing people working, so I'll give them another minute. Question. Anyone got a AC adapter? No one? Sorry, a power brick for their MacBook? No? Okay, whatever. Might cut it short. 51 minutes running, that'll work. All good. Okay, so everyone's here. Everyone's probably be able to connect. Let's try it out. Connect. All right, you should have a directory listing of /home/public. /home/public is a directory specifically created just for you, and anything that's put inside this public directory is going to be available to the public. That is to say, anybody. They're going to be able to access it via HTTP. If you want to store some stuff on the server that can't be accessed by anyone, you can either put it inside this home folder or put it inside your private or protected directories, so other people can't see it. But public is what we care about because that is stuff that's going to be available on the internet. So what do I want you to put there? Well, if you ran Foundation Watch earlier and went ahead and compiled my CSS, or if you just downloaded my stuff, you probably had the most recent version of the CSS that I had created. So what I'd like you to do is just go ahead and take whatever's inside the week 8 directory, select this entire thing, and just drag it on in. I just realized I'm uploading a whole bunch of node modules. That's actually going to take a long time. You might want to cancel what I just told you to do. I think what you do is you go down here and you select everything and you say stop and remove all. and maybe drag everything over except for the node modules folder. Node modules are a bunch of files that are only for use locally to be able to compile your Sass. And we don't need that once we actually put it online, because the stuff that you put online is going to be static HTML, CSS, and JavaScript. The deal with nearlyfreespeech.net is that it is a host that is used often just for static files. That is to say, it's not intended for you to put a fully functioning node site on there. I think actually you can. Nearlyfreespeech.net does allow you to create applications and store them there, like node-based sites, or PHP-based sites, or Ruby-based sites, or Python-based sites, or whatever else. But all we really care about is just getting up our index.html, our JS directory, our CSS directory, everything, and possibly Bower components. Everything else can probably stay as is. So I don't want to wait for all this. I think I'm at the point where it's only uploading node modules. So I'm just going to go ahead and stop it and move on. OK, good. OK, and if I go back to jeffrey.nfss.com, ta-da, there's that foundation site I made online. Yes?
In the future, like let's say you were to modify the index.html webpage, would you have to remove it from the FileZilla and upload it?
No, you would have to re-upload it, but FileZilla will ask you what you want to do. If it already exists online, I'm just going to drag this over here. Sorry, let me try that again. Trying to drag it into something that isn't a folder. There we go. It's going to ask me, target file already exists. Do you want to overwrite, resume? I don't know what resume means. That probably is if you accidentally tried to upload half of it last time. And then ask if you always want to do this. So I'm just going to say overwrite. Yep. So it will stop you from doing that, and it won't prevent you from doing that. Cool. So there we go. My site is available online at jeffrey.nfss.net. You can put whatever you want here. You can create your own site. You are free. You now have a place on the internet for you to put stuff. And as long as the 2 cents on your account doesn't run out, then go hog wild. Once it does run out, the way that nearlyfreespeech.net works is that it charges you based on the amount of bandwidth or memory or disk space that you use. What I mean by that is if a lot of people are accessing your stuff, if you got like hundreds or thousands or millions of people accessing your stuff, you're going to incur bandwidth costs. And that's stuff that they're going to start charging you, pennies at a time for. If you start uploading massive amounts of files, just a ridiculous amount of stuff, then it's going to start saying, ooh, you're taking up more disk space than we want you to. We're going to start charging you for that. Also, if you start running some programs that you've uploaded, and you have those programs running constantly, that's taking up memory. Memory is necessary for the application to just continue running, and they're going to start charging you for that too. So, again, the worst case that can happen, given that everybody here signed up without actually providing, financial information, is you're just going to shut your thing down, which is fine because you haven't paid for anything, so that's great. But once you do that, nearlyfreespeech.net is actually quite affordable. There are other services that also other traditional web hosts like nearlyfreespeech.net, which also provide pretty affordable deals. DigitalOcean is one that I hear a lot of people use, which for $5 a month gives you a lot of memory, a lot of disk space, and a lot of transfer per month. This is more than the majority of businesses or just people in general probably need, but they scale upward. So that's cool. But what if you just don't want to pay for anything at all? Wouldn't that be great? DigitalOcean, nearlyfreespeech.net, another service that I use called WebFaction, which is a little bit more expensive, but I use it. I like it. The reason that people go for this is because they want to be able to have a site that can run programming code, that can actually run your PHP, run your Node, run your Ruby, run your Python, run any language whatsoever that you can configure your site to run. You configure your host to run. But in a lot of cases, and more and more ubiquitous nowadays, is the ability to simply generate a static site like we have here, and just put it on a static host whose only responsibility is just serving you static information. One such place is called GitHub. GitHub is a place where you can put code. And GitHub has a really, really cool feature, which I'm actually surprised is free, called GitHub Pages. GitHub Pages hosts files directly from your GitHub repository. Well, why? Why do they offer that for free? Well, think about it. If you go to github.com, you go to your repository. Oops. You go to your repository. People can access this stuff, and they can download the files, and they can access the stuff inside it. You know, here we go. I'm just taking a look at all this stuff. Foundation test. Here's index.html. And if GitHub can serve me all these files and have me take a look at all of that stuff and look at all the code and download all the code and whatever, then there is exactly zero skin off its back to be able to send this raw HTML to me in a format that looks, you know, like this, or moreover is sent with a header that says, hey, this is an HTML file, display it as such, and it just displays the HTML. So in other words, it doesn't take GitHub any additional processing to be able to serve this to you as a web page as it does to serve this to you as text. Because it's just a response with different headers. The same response, different headers. This actually costs them more money to serve to you because not only do they have to send you this code that's all syntax highlighted, they have to serve the footer and the header and the little icon there and a whole bunch of other little images. It's actually pretty expensive to load this page versus just this page. So if you think about it, it's free for them, or they're already paying for it, so you might as well be able to host full sites. Cool. So why don't we do that? Why don't we take the little test foundation app that we created and put it on GitHub for everyone to access. So here's what I'd like you guys to do. I'm going to go ahead and create a new repository, and I'd like you to do the same. So just from the main page of GitHub, click the green button to add a new repository. github.com/new. I want you to create a repository. I'm going to call it, I don't know, Foundation-10. I'm calling it Foundation 10 because 10 is the series of this class. If I do 11, then series 11, then I'll do Foundation 11. But here we go, Foundation 10. You don't have to add a description. You don't have to make. You should make it public. If you don't make it public, then it can't be GitHub pages because it's private, right? Don't worry about a README. In fact, don't do that because we're going to initialize a Git repository locally and push it to Foundation-10. Okay. Next thing that we want to do is go back to the command line. If you are not already inside Foundation Test, I'd like you to go there. I'd also like you to quit out of Foundation Watch if you're running it. You just do a Control-C to quit that. You should be able to type things into your command line. Oops. Oops. Okay. And what I'd like you to do is initialize a new Git repository right here. Git init. Then you pretty much follow exactly what's going on right here. You don't have to add readme.md. Skip that. In fact, I think readme.md is already there. If you take a look, yeah, there's already a readme, so you don't have to add it. What I'd like you to do actually instead of git add readme.md is git add dot, which is going to stage everything for commit to GitHub. That is to say, the next commit that you make, all these files are going to come along with it. By the way, in case you're wondering, Bower components and node modules probably are not going to come along with it. Actually, I'm sorry. Bower components, are they going to? Let's see. Oops. Yeah. Sorry. No, they won't. That's odd. I wonder if that's okay. Let me see something. I'm not sure if this will actually work. Let me think about that. Well, let's see what happens. There's a little file that's been generated called .gitignore. Gitignore is a file that tells your local version of Git that certain things should not be committed. One of those things is node modules. Remember what was happening when I was uploading this massive amount of node modules and I decided to just cancel it? That's a whole bunch of stuff that's not necessary for the site to actually load. That's just stuff necessary for development. And those have been installed based on another file called package.json, which tells which node modules should be installed. So if GitHub needs to do that, it'll take care of it. It does not need its own version of all the node modules that I have installed. So that's why they're ignored and not added to my Git repository. So anyway, I've done a git add to stage everything. Now I'm going to do a git commit to commit everything. Remember to add a message, do a -m or a -am. I'm going to say initial commit. These files have been added, and I'm going to go ahead and do a git push. Oops, I can't do a git push because I haven't configured where on GitHub I'm going to push it up to. To do that, I'm going to go over to git remote add origin, just copy and paste this and put it there. Of course, do not type Jeffrey HW here, copy and paste whatever you created. And then finally, git push -u origin master. And now it is uploading the site to GitHub. And if you reload this page, it should be available right here.
Can you explain quickly what the -a flag does?
The dash what?
The -a flag. You did
Oh yes, -a makes it so any files that are already being tracked are going to be staged for commit. So that is to say, this is actually unnecessary. I didn't have to do this here since I already did a git add dot.
Yeah.
Git add dot starts to track or stages for commit any files that have not yet been staged or tracked. That is to say,
it just combines the add and commit into one.
yes, but it only stages files that are already being tracked for commit. It's not going to explicitly force to add things that are not being tracked. So with the very first commit, you do have to do a git add dot, which adds everything, and then a git commit -m. This A in this case doesn't really do anything, but for subsequent commits, if you make any changes, then this A flag is going to automatically stage them for commit and then commit them. It's all in one fell swoop. So yeah, just a little speeds things up. But you do need a -m for the message. Okay, so everything's online. That's great. So how do I access this site? Well, I have to do one more thing. I have to create a new branch. Can I do that from here? I think I can. Hello? Oh yeah, here we go. One branch. Can I? No, I can't create a branch here, so I guess I have to do it from the command line. Okay, so. Oh, find or create a branch. Oh, cool. Let's create a new branch called GH-pages. And it's going to branch it from master. So that is going to say it's going to take all the files that are currently in the master branch, which is here, and create them here. Now we have the GH-pages branch. GH-pages, make sure it's exactly that. That is a special branch that as long as you have that branch in your repository, it's going to treat this like the main file, the main folder of your website. So if you access the website, it's going to load up index.html. How do you load up the website? I think it is github.io. Sorry. No, I'm sorry. It is this. It is your username .github.io / the name of your repository. So foundation/-10. Yep. It kind of worked, but the CSS didn't exactly work, and the JavaScript probably doesn't work either. But as you can see, it has loaded up my HTML file. So that's a good start. You know, just change this to your username, and the same thing should happen as long as you created your GH-pages branch. So why is it not fully working? And what sort of effort do we have to make to get this to actually work properly? Well, the first thing we can do is take a look at our network panel and see, look, we're getting a bunch of 404 not founds. That's interesting. Why is that? Well, it looks like it's looking for app.css in foundation10/css/app.css. So why is it not there? To be honest, I actually don't know. It's probably because it's part of the gitignore file. Oh, it totally is. Yeah. So what I have uploaded to the GH pages branch is although I even ran the build command, the fact that this .gitignore is there in the first place means that certain things that are necessary, certain things that have been built out, or certain things that have been installed, like node modules, Bower components, which are kind of front-end node modules, and CSS files, which are built by that Sass watch command, or foundation watch command, are not being included. So I think the easiest way to get this to work is to remove a few things from gitignore, add them, and then push them to the GH pages branch. Or actually have a different gitignore just for this branch. So certain things that are not included in the master branch can be included here. So this is what I'd like to do. I'm going to go ahead and do a git checkout -b gh-pages locally. That means that now I'm on the branch GH pages. But actually, maybe I should have done git pull before I did that, because, oh dang, yeah. There is no tracking information. Oh geez. Maybe I shouldn't have done that. Let me see. Git branch set upstream to origin GH pages, GH pages. Okay. If you, after running git pull, don't have tracking information for this, and you need to specify which branch you want to merge with, which is available online, which is GH pages, you want to run this command. But you need to replace branch bracket with GH-pages. So copy and paste this, command V, and git branch set upstream to origin. Just replace this with GH pages. Just bring your cursor over there and just replace branch with GH pages. And then write GH pages a second time, the space between them. And there we go. Make sure that we've got the latest stuff from GH pages. We're good. Okay. Now here's where it gets a little tricky. I want to be able to edit gitignore, but I don't want to use Vim. Vim being the built-in text editor that comes with that's available via your terminal. It's very hard to use. And this is a beginner level class, and I don't want to be able to teach you how to do that. So I want to be able to open up gitignore with our text editor. Only problem is that, as you can see, there is no gitignore here. Why is that? It's because it starts with a dot. Files that start with a dot don't show up in Mac OS or Linux by default. They might show up in Windows. If you're using Windows, then lucky you. But they don't here. So we can do two things. We can temporarily rename it to something that we can see, or we can try to edit it from here by using a command like open.gitignore. This will only work on Mac OS. But it should open it up in a text editor, and if it doesn't, then it might ask you what you want to open it up with, and then you choose a text editor. Is that working for anyone? Open.gitignore. You know, if you're on Windows, then it might be explorer.gitignore, or you just be able to find it in Windows. You know. But anyway, what we want to do here is that now that we're on the GH pages branch, I'm going to remove a few things so the proper stuff can be uploaded to the special GH pages branch that has all the built stuff we need, such as Bower components and CSS. We need those two things. Bower components is where jQuery is installed, and jQuery is necessary for Foundation's JavaScript to run. The CSS directory is where our compiled CSS goes after the Sass command goes through it. So I've removed those two from there. Now that I've removed it, I'm going to go over here and do a git status again. And now you see that the three things have happened. Gitignore has been modified, true, and two things that are untracked are present, right? Because now that gitignore has been modified, it now knows to look for them. So I'm going to do another git add dot. And that's going to start tracking these two things and all the files inside them. If I do a git status here, you'll see, oh my goodness, that's a lot of stuff. That's a massive amount of files that need to be checked in. But they do need to be checked in because they are necessary for, well, actually, a lot of this is SCSS, so it's not necessary. It's really only the distributed stuff that's necessary. But anyway, most of this stuff is necessary for the site to load up properly, in addition to CSS/app.css. So now that we have added them, staged them for the next, or started to track them and stage them for the next commit, we do git commit -n adding ignored files. Actually, I'm just going to say imperative add ignored files. So the command I just ran looked like this: git commit -n add ignored files. Really, you can say whatever you want here. I mean, like it's just a message for you, but I like making it descriptive about what I'm actually doing. Now that I've committed it, I can now upload my commit to GitHub by doing another git push. Okay, might take a second to upload that stuff because that's a lot of files. But now, if we go back to our GH pages branch and reload, you'll now see CSS and Bower components shows up. And if that worked, then all you have to do is go back to this again, load it up, and voila, we've got our boilerplate stuff, and we probably have JavaScript on the page that works, maybe, I'm not sure. We want to check to see if all of our HTTP requests are 200s, and it looks like they are. Some of them are 304s, which is great, which means they are cached locally. I'm communicating with GitHub. I'm saying, hey, do I need to get app.css? Based on my request headers, I have a cached copy somewhere. If modified since, if the file has been modified since September 20th, 2016, which is tomorrow, then send me a new one. Otherwise, don't. And this response is actually coming locally because the status code is 304, meaning I don't need to send you anything new. It's great, though. So there we go. Here we go. We've got our static site hosted on GitHub, and it literally is available for everyone, and it is free eternally as long as GitHub exists. So that is definitely a good incentive for you to create a static site that doesn't have any any local databases or any sort of ability to have to compile code on the fly. And if you do do all this pre-compilation before the fact, then well, you're going to save money. For static sites that still need some sort of information like database access or whatever else, I think next week, possibly, we're going to start talking about AJAX. AJAX is the ability for JavaScript to make HTTP requests. So far, we've been talking about browsers making HTTP requests, making HTTP requests based on the image tags and the link tags and the script tags inside your HTML. But JavaScript code can also make requests. And that's what we're going to talk about next week. Sites like this that need to request information in a programmatic form, but they're static sites. They're not backed by any databases. They can still make AJAX requests to specific sites that are or servers that are running databases, so they can make that sort of request separately. So the whole separation of concerns of having your static site in one place and your database somewhere else, hosted elsewhere, or your API sitting on top of your database, your application programming interface, is one very common thing that we're seeing very often because it makes your site a little more modular in some ways. So we'll talk more about AJAX next week, and we'll be using nearly freespeech.net for that as well. Yeah, I think that is all I wanted to talk about today. Do I have any more questions from? No, good. Anything else? Anyone else wants to know about HTTP, SFTP, GitHub stuff, whatever? Yeah.
What does the line mean again?
What does the what mean?
For status codes? You said they started.
Oh, 100 something. Actually, that's a good question. Let's see, status code definitions. What do they mean? Informational. Request received, continuing process. That's what happens when the server has something to send back to you saying like, we're in the middle of some sort of transaction here where I'm still talking to you, but here's some information that we're ready to start. Like before you can make a WebSocket request, you need to send an HTTP request saying, I'd like to establish a WebSocket connection with you. And then it says, okay, here, switching protocols to WebSocket. So that's where a 100 means the next thing is going to happen now. So I guess that's what it means. So, yep. That's about it. I do have a lab on Thursday, as usual. I don't know if I have an assignment for this class usually. Nah, I don't. So not really much of an assignment. What I would say is put up your personal projects on the internet now. You know how to do it via GitHub pages. You know how to do it via Nearly Free Speech or any other sort of similar host where you can use SFTP to connect. By the way, any server that supports SSH also supports SFTP because it's the same thing. It's just basically the way that you can securely copy files, SCP files, to a server. So you can use FileZilla to graphically transmit any files that you can SSH to any server that you can SSH to. So if you know what that means, if you know how to do it, then you're set. Cool. I think that's it. So I will see. Damn, I missed the show. No problem. Good thing it's being streamed and being saved on YouTube. So come back to it later. All right. No problem. See you guys later. Thanks for coming. And goodbye.